So our last presentation is pre-recorded by John Russell, who's part of AFRL. And we asked him to help the novices like me on this symposium understand what everyone's been talking about all day today. And as he said, making sense of the acronym soup. He's done a fabulous job here. As I said, this is pre-recorded, so we won't be able to ask questions. And then I'll just do a quick wrap up. It's also short. It only runs 15 minutes. So I am going to stop sharing and turn it over to Kathy to run the video that we pre-recorded with John Russell. Thank you everyone for joining us today. It's been a long day and you've heard a lot about the various DoD programs and the lead for each one of these specific areas. We're going to wrap up today's session with a great presentation by John Russell that'll help you navigate the alphabet soup of acronyms in putting together your proposals and understanding what is going on if you want to put in a proposal to the U.S. Air Force Research Lab. Dr. Russell has joined us today. He is the chief of the Air Force Research Laboratory's Structure and Technology Branch. And in this role, he is the senior manager of a team that develops and transitions new airframe structure technology for safety and efficiency in future Air Force weapons system. To do this, he builds partnerships with customers across the Air Force, across DoD, other government agencies, industry, and academia. In addition, he's one of the leading experts on composite materials. Dr. Russell has a doctor in science degree in chemical engineering from Washington University in St. Louis, and he is also a fellow of SME, the Society of Advanced Materials and Process Engineering, SAMPE, and with the Air Force Research Laboratory. So with this, let me turn over to you, John, to put your presentation up and share your wisdom that you've gathered.
All right, thank you, Talinda. And thanks to everybody for being on the talk today. I appreciate being able to talk to you. Let me pull up my slides here. All right, before I go forward, Talinda, can you confirm that you have full screen?
Yeah, we've got the full screen and we hear you very well.
Great, thanks. All right, so good afternoon, everybody. As Talinda said, my name is John Russell, and I'm here to talk to you really not about the technology side of things, but about the language of DoD, making sense of the acronym soup, the language of the DoD, and what it means for science and technology. So it's a long path from a technology concept to getting your technology on an airplane and then full supply chain integration. In between these two endpoints lies proof of concept, benchtop demonstration, characterization and testing, proof of system integration, pilot scale, and then advanced manufacturing, and then eventual adoption into the full supply chain. Each step in this process requires increasingly complex participation by technical support, business development, sales, marketing, production, accounting, and so forth. But navigating that path to technology transition is difficult enough. On top of that, the Air Force has its own particular language in describing everything, including funding, acquisition, and technical maturation. You might have heard of some of these terms and acronyms before, things like color of money, RDTE, O&M, PEs, CIIs, DoD 5000, TRL, and MRL. Now, these are likely going to have you saying WTF at the end of the day. Now, many people don't understand how the system works in general when they don't understand the language as well. So the purpose of today's discussion is to define all these terms for the S&T community so that you can have a better understanding of how you can work with us. So I'll go through all of these one by one, well, other than WTF, because you know that one. And then we'll talk about the definition and the importance of each term. So color of money. So this does not refer to the Tom Cruise movie. This does not refer to Monopoly. You know, color of money is about different appropriations from Congress to run the Air Force. An appropriation is a fund set aside by Congress permitting federal agencies to incur obligations and to make payments out of the Treasury for specified purposes. So within the Air Force, there are two overarching types of appropriations. There's investments and then operations and maintenance. Each appropriation is designated by a 4-digit numeric identifier for the Treasury Department to use in execution tracking. And you can see all those numbers listed here on this chart. But the important one to know about for S&T is 3,600 for RDTE for the Air Force. So that's where all of our S&T comes out of. So next is RDTE funding. So we'll drill down into that. So in particular, you are going to want to know about 6.1 through 6.3. That's the science and technology budget. So 6.1 is basic research, and it's about far-sighted, high payoff research that provides the basis for technological progress. It's about increasing fundamental knowledge and understanding. This is really mostly used to work with universities. The next step up the ladder of maturation is the 6.2 applied research funding. So things that graduate out of basic research flow into applied research, where you try to take a look at solutions for broadly defined military needs. And these efforts really establish an initial feasibility and practicality of proposed solutions. The next step up in maturity is 6.3 advanced technology development. This is where you start to work development of subsystems and components and things that really take a look at simulated environments for what the military needs. Projects in this category have a direct relevance to identified military needs. And just to round it out, just so you're aware, 6.4, 6.5, and 6.7 are really about taking the technology developed out of S&P and trying to apply them into a weapon system to meet current or near-term operational need. Then 6.6 is about RDTE management and support work. So the next, drilling down a little further more into RDTE are program elements. So program elements are a code within a budget category that represent a specific military capability or support activity. Congress designates how to spend funds within each color of money through the program elements. What I'm showing here in this table is an example of the 2020 defense appropriation for the Air Force for its basic research line and part of applied research. So you can see program elements for basic research sciences, university research initiatives, high energy lasers, et cetera. Now, oftentimes you may see here the amount in the final bill that's passed by Congress and signed by the president is different than the president's initial budget request. A program element could increase or decrease from the president's initial request based upon Congress's view of the area. So a companion to that term then is congressional interest items, or CII. You probably know these better as congressional ads or earmarks or pork. These are provisions inserted into appropriation bills that direct funds to a specific recipient while circumventing the merit-based or competitive funds allocation process. So this table here shows the 2020 appropriation for the Air Force's 6.3 funds for the Manufacturing Technology Program. As you can see here, Congress inserted several ads into this program element. Now, how these come about is typically an organization, such as a company, university, nonprofit, work with their representative or senator to include an earmark in a program element. Now, an important disclaimer, executive branch employees, such as myself, we cannot work with Congress to insert CIIs into the budget. That is a big no-no. We support the president's budget. However, if you plan on inserting an earmark into somebody's program element, let those people in the executive branch know that it's coming. It's really better for everybody so that there's no surprises It really improves the quality of the work that's going to be done with that CII funding. So next, let's move on to the DoD 5000. These regulations describe the DoD's acquisition process. They provide the policies and principles that govern the defense acquisition system and that form the management foundation for all DoD programs. And they identify the specific statutory and regulatory reports and other information requirements for each milestone review and decision point. So to put this in context around something you may have heard of, the F-35, Boeing, McDonnell Douglas, and Lockheed Martin were awarded contracts for material solution analyses. Then at milestone A, the DoD down selected to Boeing and Lockheed to move into the next phase, technology maturation and risk reduction. During this phase, both Lockheed and Boeing built and flew demonstrator aircraft. Then at milestone B, the government down selected to Lockheed Martin to go into engineering and manufacturing development, or EMD. And then finally at milestone C, Lockheed was awarded a contract for low rate initial production. So let's switch gears a little bit and talk about tech maturation. I'm sure many of you have heard the term TRLs, or technology readiness levels. These talk about the level of maturity of a technology relevant to its use in an application. These have been around for a long time now, and you can see they start from TRL 1, basic principles observed, going all the way up through TRL 9, so proven in an operational environment. So TRLs provide a common language to assess performance maturity of a technology and its plans for future maturation. And it really helps you understand the risk in trying to transition the technology to a weapon system application. So in general, if you tie these back to funding and funding types, so 6.1 basic research usually funds TRLs 1 and 2. The 6.2 applied research funds things that are generally TRL 3 and 4. And then 6.3 funds things that are TRL 5 and 6 to mature things up the ladder. The one thing about TRLs, though, is that questions still remain. So these talk about individual technology demonstrations, but what if you need more than one item? What if you need to build a whole production run? Is the level of performance of your demonstration going to be reproducible? Do you know what these things are going to cost once they're in full production? Can you make these things with the average run-of-the-mill factory worker rather than a host of PhDs? And finally, do you have the key materials and components available for a full production run? So to address these, we take a look at the manufacturing readiness levels. These were developed in the mid-2000s to answer those questions on the previous chart. MRLs are assessed to define the current level of manufacturing maturity, identify shortfalls and associated risk and costs, and then provide the basis for a plan for manufacturing maturation and risk management. And it's important to note that manufacturing readiness assessments are now a mandatory part of the source selection process in major acquisition programs. In addition, they're used also in R&D programs as we try to mature manufacturing along with the technology at the same time. Now, as we look at manufacturing readiness levels, it's not just one overall number. There's a number of things we need to take a look at to make sure that we know the manufacturing maturity level or manufacturing readiness level. So we take a look at the technology and its industrial base. Are the designs mature? Do you really have an understanding of your costs and your funding sources? Do you know what materials you're going to use? Do you have the process controls available? Do you have a quality management plan in place, including a plan for your suppliers? Is your workforce prepared to understand this technology when it gets into production? Do you have the facilities and the capital equipment available? And finally, do you have a manufacturing management plan? So just to wrap up, I hope you found this talk useful. It helps to make sense of the acronym soup that defines the DoD from its major weapon systems down to the S&T community. So I've defined some of these key terms of importance for the S&T community so that you have a better understanding of how you can work with us. I look forward to working with all of you soon. Thank you very much.
Thank you so much. That was fabulous. It definitely clarifies for all of our participants in this webinar on how to proceed, how to figure out what the language is that's being spoken. I guess I have one question, which is one that you and I have talked about a lot, and that is, I see you are a lead on composites. So could we talk a little bit about composites research at DoD?
Sure.
How do you see, I guess it's really with AFRL, the composites research programs proceeding, and what kinds of programs are you interested in?
So we run the gamut from developing new materials and processes to developing manufacturing processes to developing designs for the use of composites and systems. And even though we're separated in 3 different organizations, we all work together very well to try to move this forward. We're constantly looking at developing new materials for things like bringing 3D printing into composites. We're always looking for materials that have better properties in terms of strength and stiffness, as well as temperature capability. For manufacturing, we're trying to take a look at how do you bring the Industry 4.0 environment into composites. Composites has been pretty analog, and how do you take advantage of some of these new technologies like augmented reality, like digital asset tracking, and things of that nature to move the ball forward there. And for designs, what's the next step in terms of large integrated and bonded structures to make designs close for future aircraft concepts? We're going to need to improve the way that we do bonding in aircraft structures. And then finally, this whole concept of attritable structures. So airplanes with designed specifically for limited life from the get-go. We may be able to use designs and materials and manufacturing that typically aren't used in aerospace to try to take advantage of the relaxed requirements for airworthiness and airframe structural integrity that we anticipate are going to happen.
Excellent. That's a great answer. Thank you so much. And John, we really appreciate your taking the time to present and very good information. And we are your perfect wrap-up speaker for us. Well, thank you, everyone. It's been an incredible day. Let me just share a couple of things with you. First of all, thank you to all of our speakers. We all have learned a lot today, and I'm sure it's hard to write notes and you're wondering, can I get a copy of the presentations? All the proceedings, we're going to do proceedings from this day today, and they will be posted with the videos on the UMDC website. And that's the brand new, this is the first time we're really rolling it out. It's not 100% finished, but we are able to, that's how we were able to run the YouTube, was through the UtahDefenseManufacturing.org. We really have to big shout out and thank you to the Office of Local Defense and Community Cooperation, formerly Office of Economic Adjustment, for their leadership in putting this program in place. And we're the first year. There is funding for FY 2021 and consideration for FY 2022. So hopefully the funding will keep coming through as we do good things like we've just done today to move the ball forward for the warfighter and our industrial base. And also we have a big shout out to the Office of the Governor's Office of Economic Development, who put the proposal in and won the grant. And finally, in this continuing program for Utah Defense Manufacturing Community, look forward to having 2 additional symposiums this year, one on defense manufacturing workforce issues, and the second is on defense manufacturing supply chain issues. So with that, I thank you. I thank Kathy Bloomquist for all she's done to put this together. And Grow Utah, Justin Vaught has just done an awesome job in figuring out how to get all this technology to work. And our brand new Director of Marketing, Dustin Cedarholm, for working with us and putting this fabulous event together. So with that, we will conclude. Thank you, everyone.